Good morning, everyone. I'm Engineer Charlie Agnol, and our topic for today is all about hydraulics. So today is September 18, 2021. So discharge or flow rate is the amount of fluid passing through a section per unit time. So discharge denoted by letter Q is equal to volume all over time. So we have here our first formula. Q is equal to volume all over time. The unit is in cubic meters per second. So we have here our example number 1. Calculate the discharge in the cylindrical container filled with water at height is equal to 6 meters in 2 minutes. So we have here our drawing for our cylindrical container, which has a radius that is equal to 5. This is in 5 meters. At about height filled is equal to 6 meters. So we are asked to calculate the discharge. So discharge, our formula is equal to volume all over time. So the discharge or flow rate is equal to volume over time. So we first have to solve or calculate for the volume of the container, and time is already given. So that's in minutes. So to solve for volume of the cylindrical container, the formula for volume is equal to pi all over 4 times the diameter at the bottom multiplied by height. So area at the bottom multiplied by height is equal to pi all over 4. Diameter is, so we have here radius that is 5 meters. The diameter is double, so that is 10. 10 squared times height, which is 6 meters. That's equal to 150 pi in cubic meters. Then we have to solve for the time in seconds. So we must convert time given 2 minutes, convert that to seconds. So that's 1 minute is equal to 60 seconds. Let's multiply, we get your time equal to 2 times 60 is 120 seconds. Then we substitute the values in our formula. Q is equal to volume that's in cubic meters, so 150 pi cubic meters per 120 seconds. So our flow rate is just equal to 3.93 cubic meters per second. So the discharge in the cylindrical container filled at about 6 meters high in 2 minutes is equal to 3.93 cubic meters per second. Also class, your discharge or flow rate, if you do not have the volume or time, we can also solve for flow rate using area and velocity. So we have here another formula for flow rates or discharge. So that's equal to area times the velocity. The unit is equal to cubic meters per seconds. So discharge is just equal to area times the velocity. So we're talking about the cross-sectional area multiplied by the velocity of the fluid flowing. So let's apply that. Here in our example number 2, calculate the discharge in the stream with a cross-sectional area of 21 square meters and the velocity of flow is 0.3 meters per second. So we have here our drawing for the stream, which has a total cross-sectional area given that is 21 square meters and the velocity of flow is 0.3 meters per second. So our formula here is equal to Q is equal to area times velocity. Discharge is just equal to area times velocity. our area for the stream is 21 square meters, and the velocity of fluid flowing is 0.3 meters per second. So 0.3 times 21 is just equal to 6.3 cubic meters per second. So this is the discharge of the stream. And for another topic, continuity equation. What's continuity equation? Classic states that in the case of a steady flow, the amount of fluid flowing past one point must be the same as the amount of fluid flowing past another point. Meaning, the volume of fluid flowing at this point, area 1, if, say we call this your pipe, the fluid flowing on your pipe at point 1 is just equal to the amount of fluid flowing at your point 2 or your area 2. Okay? So notice that the cross-sectional area at point 1 is not equal to your cross-sectional area at point 2. But because of this continuity equation, so it says that the amount of fluid flowing past one point must be the same as the amount of fluid flowing past another point. Continuous. So the volume here of fluid flowing is equal to the volume at point 2. Okay? So the discharge is just equal to area times velocity at point 1 is just equal to area times velocity at point 2. Okay? So we call that your volumetric flow rate. Q is equal to area times velocity. And the unit is in cubic meters per second. And you also call that your mass flow rate if you multiply your density times your flow rate. So density times flow rate, or density times area times velocity. So your unit here is in kilograms per seconds. And we also call that as your weight flow rate if we multiply your unit weight of fluid flowing times your flow rate or your discharge. Okay? So the unit for weight flow rate is in newtons per seconds. So we apply this continuity equation on our example number 3. Suppose water is flowing through a pipe of diameter 1 centimeter with the flow velocity of 2 meters per second. If the pipe widens to a diameter of 3 centimeters, what is the velocity at the bigger pipe? Calculate the discharge. So we are asked to find for the discharge and the velocity. So we have here our drawing. We have here your pipe at section 1, so we call this your section 1. And it flows from point 1 with a diameter of 1 centimeters, velocity of 2 meters per second. Is flowing up to point 2. Okay? So at point 2, the diameter of your pipe is just equal to 3 centimeters. Okay? So the velocity is unknown. We are asked to solve for the velocity. Actually, class, we can already compute for the discharge if we know this continuity equation. Because it says that the volume flow or the volume flow rate at point 1 is just equal to the volume flow rate at point 2. So we can prove this by calculating the volumetric flow at point 1. Then we can check the flow at point 2 after we solve for the velocity at point 2. Okay? So we can solve for the discharge at point 1. So that's equal to area times velocity at section 1. So area 1 is equal to So we have here 1 centimeter. So we substitute that, or we convert that to meters. So pi all over 4 times diameter in meters. So that point 0.01 meters squared multiplied by the velocity. Given velocity is 2 meters per second. Okay, so we take the area, take pi over 4 times 0.01 squared multiplied by the velocity, that's 2. Okay, so the discharge at section 1 is just equal to 0.000157 cubic meters per second. Okay, so we could solve for Q1. And to find for velocity at 2, by continuing the equation, discharge is just equal to area 1 V1 is equal to area 2 V2. So we have here area 1, velocity 1, and your area 2, we can solve for that. And the only unknown now is the velocity at section 2. So let's substitute. Area 1 will be equal to pi all over 4 times the diameter is 0.01 from centimeters to meters. So change the unit. Multiplied by the velocity, 2 meters per second is equal to area 2 pi all over 4 times 3 centimeter, convert that to meters, so we have 0.03 squared times your velocity 2, which is unknown. Okay, so velocity 2 is just equal to area. So what's the area? So we can just write it down. 0.01 squared times 2 meters per second all over area at section 2. 0.03 squared. Okay? So we have here velocity at section 2 is equal to. So you try to solve also. Bring out your calculator and let's check if we get the same answer. So I get 0.222 cubic meters per second. So that's your velocity at section 2. So we check if we get the same amount of discharge at section 2 if we use this velocity 0.222 meters per second multiplied by the cross-sectional area at section 2. So we have here pi over 4 times 0.03 squared. So let's check. So what do you get? You get the same answer, 0.00157 cubic meters per second. If you get the same answer, then that's correct. Okay? So that's all. Thank you.